after knowing our principal and deviatoric and hydrostatic stresses, alright, let's talk about what is brittle material and ductile material and how they're linked to all the stresses that we have been discussing all along. And with this video is just a vague video on the definitions, alright, and especially on the ductile material. Okay, so in order to start, we'll start off with the principal stress. You know that principal stress can be expressed as sigma 1, sigma 2, sigma 3, 0, 0, 0, 0, 0, 0, 0. Correct? But what is the meaning behind them? The meaning behind this, sigma 1, which often is a very large value, alright? Or I don't know whether, it should be large. It is called the tensile stress, and it's a maximum tensile stress. And if you were to visualize it in terms of graphically, where's my thing? This is our maximum tensile stress, our ultimate stress. Alright, is where it's going to before it breaks, something like that. So maximum tensile stress is the ultimate tensile stress. Alright, and if you were to talk about it, alright, in terms of visually, sigma 1, alright, tensile stress is in terms of a stretching phenomenon. Contrary, on the other hand, if we have a pressing, then we're talking about compressive, and therefore sigma 3 is a maximum compressive stress. Okay, and sigma 2 is simply between them, and we can write the inequality as 1. Okay, and brittleness is simply sigma 1. Alright, if you talk about brittleness, sigma 1 is we are trying to look at this value over here. Okay, because it's talking about max ultimate tensile stress before it breaks. Alright, so before it breaks, talking about brittleness of most of the case. Alright, therefore we want our tensile stress, max tensile stress, to be lower than the ultimate tensile stress. Alright, and this is in fact the material property which I've shown you earlier, right, in the previous in the slide. Alright, and because this stress strain curve simply talking about, it describes the material. Different material have different stress strain curve, that's all. Okay, let's come back here. Alright, different material. Okay, and if you know that you design a certain stuff, you need a safety factor, right? So we have a safety factor multiplied with our system's maximum tensile stress. Alright, so I call it N, and therefore I can rewrite this sigma 1 as simply S ultimate over N, where this is the failure criteria just before it breaks. Alright, something like that. Okay, and you may wonder if I can visualize ultimate tensile stress or max tensile stress, or not ultimate but rather max, okay, then how do I visualize max compressive in terms of curvature or in terms of graph? Then this thing I don't know okay. So therefore this is what I say in the video, that I'm just vaguely going through it. I'll just show you that meaning. Ductile material is more vaguely described. Alright, ductile material is more vaguely described. How does it link to, and where does it link to? It's gonna link to the principle of the deviatoric stress. Alright, this is the deviatoric this is the deviatoric stress. This is the principle of the deviatoric stress. I talk about it, right? And the deviatoric stress invariant J2, alright, or the constant for sigma, this is for sigma square, this is for sigma, and this is for sigma to the power of 0. Alright, and there will be like some sigma cube. Okay, but I just don't go through it. But J2 itself has a significant meaning to ductility. Alright, it's related to von Mises U criterion. It's talking about yield stress. Alright, and the yield stress is simply I think somewhere here. Okay, somewhere that it will actually deform plastically. Alright, this means that it will deform permanently, in other words. Alright, and therefore von Mises yield stress or yield criterion is related to our begins when the second devolteric stress invariant J2 reaches a critical value. Or in other words, this invariant that I was just said earlier, when it reaches a certain critical value, then it is considered very ductile, maximum ductile or max yield strength. Alright, so this value, I don't know what the hell is going on. Okay, and therefore this is just some meaning of it. Alright, then and we just say that the von Mises stress, alright, must be lower than the yield stress. That's all. Okay, I think in the later parts we'll talk about it, but just for the concept of ductility and brittlity, this is it. Okay, so I'll see you in the next video. Goodbye.